In this next example of solid edge ST5 simulation, we're going to take a look at heat generation. And heat generation is only active when you're in an assembly environment. So what we need to do is build a study. Again, we're going to use steady state heat transfer. And then we're going to select the two components. Again, heat generation, basically identical to heat flux with one exception. Heat flux is transfers energy through a unit area, where heat generation transfers energy through a unit volume. In other words, it only allows you to select components as opposed to faces. So when I start heat transfer, you notice there's no option there to pick faces or edges. You just pick the component that you want, and in this case we'll get this design body, this button that generates heat, and maybe we'll just put it at say 25 watts. And then what we can do is we will, to get rid of the heat, what we're going to do is use convection, and I'm going to apply it to this entire feature. Film coefficient, basically how heat leaves a surface, and you know, depending on the material. So film coefficient, I'm just going to leave at 1, and ambient temperature, which is 20 degrees centigrade or about 68 degrees. So I'm going to go ahead and leave that. I'm going to turn off the loads and the convection, and go ahead and run the solve. Now it tells us that you are solving a heat transfer study without connectors. Thermal loads, except enclosed radiation, would not be able to transfer heat between between bodies that are not connected. So it's telling us that we really need to set up some connectors. Now I can proceed. It does allow me to proceed, and we'll talk a little bit more about that later, but I don't want to. It's a good reminder. I can just come in and run auto connect. We only support glued connectors in heat transfer, so I'm going to go ahead and create this one connector that we have, and then when that's done we just simply click on the solve and we let her run. Now this takes about 40 seconds, so I'm going to short a little bit by pausing during some of this process. Now it's applying the loads, and now it's solving the heat transfer study, and now it's processing the results. And what will occur is the button, the red button, is generating 25 watts of heat, and you can see that the heat is convecting out through all of these surfaces. Now, of course, at any time, if I want, I can turn those connectors off as well, and we can, zoom up, and you can kind of see how the heat's transferring through these components. And our high temperature is 293, and our low temperature is 278. Now, if I come out, and let's just say I want to make a quick change, so I'm going to go to a face select mode, and I'm going to select these top faces, and I'm going to move them upward, and I'm going to use the tip option so I can just kind of bring them up very quickly. And then I'm just eyeballing this. I'm not moving them in any particular order. I'm going to use the tip option here as well, so I can bring these down just to kind of extend them out a little bit. I'm going to do the same with each side. And one more side. And you can see that we've extended our wings, if you will, that are being used for the convection surface. Now I'm just going to simply rerun and see where that leaves us. And now it's solving the heat transfer. And now it should start processing the results. And when that's complete, you can see that it did drop our temperature just by expanding the fan or these blades out a little bit farther, so that the heat could convect out through more surface area. So it's just kind of a little demonstration of heat generation. Again, not a whole lot different than heat flux, other than the fact that you're doing unit volume as opposed to unit area. So this concludes this demonstration.